Hey class, welcome back to our science subject and welcome back to our energy and transformation book. We are getting into chapter 3 today. Energy and speed are related. We've covered chapters 1 and 2, so if you haven't watched those, please go back and watch those because those are the foundation and will build up to what we're going to be learning in chapter 3. With every chapter, remember you have to do your chapter vocabulary. And please use the definition from the book so I know that you are getting into the book. Please don't copy and paste the definition from Google. Please use the definition from the book. And then also you'll participate in the big question discussion post. With that as well, please don't copy and paste your answer. Please use your own words to be able to get full credit. So last time we talked about how moving objects have energy. We had some examples of a basketball player and how a basketball player uses his muscle to move throughout the court and then also to be able to move the basketball and dribble it up and down or to throw it and pass it to a teammate. We talked about the pendulum clock, how the pendulum has energy and is moving the gears to move the second hand, the minute hand, or the hour hand on a clock. We talked about windmills, how windmills, the wind gives the blades energy, and that energy is stored as electricity. So now we're getting into our chapter 3. So let's call attention to our big question. How are energy and speed related? That's what this chapter is going to be talking about. So as we read, let's look for answers on how energy and speed are related. Imagine catching a ball in your hand. If the ball is thrown gently, it doesn't hit your hand very hard. But if the same ball is hurled with strength, so thrown with a lot of force, it hits your hand hard and it stings. Yeah, that hurts. So why does it sting? One reason, because of the greater speed at which the ball was moving. So let's pause and read this definition with me, Gabriella. A measurement of the distance an object travels over an amount of time. So the measure of the distance, so you could say, for instance, driving, right? A mile, an object, a car, travels over an amount of time. So, the speed limit on 66 kind of by the shops downtown is 25 miles per hour. So the car is moving and could travel a total of 25 miles in 1 hour. So speed is a measure of the distance an object travels during an amount of time. One unit for measuring speed is miles per hour. Many countries use kilometers per hour, or kph, as a common unit for speed. When you ride in a car traveling 50 miles per hour, which is about 80 kilometers per hour, that means you'll move a distance of 50 miles or 80 kilometers in that hour if the car stays consistent. So if we look at this picture, and it's talking about baseball and a picture, and we look at this picture of this baseball player, some baseball pitchers can throw a baseball 100 miles per hour. So, and players wear those gloves to protect their hands, right? Because that ball is coming very fast and very hard. Greater speed is related to greater energy. Objects with greater energy cause greater changes. So remember, energy is the ability to cause change. When you catch a ball, the motion energy from the ball causes a change when it hits your hand, which will cause greater change, a ball moving slowly or a ball moving quickly. So if I throw a ball softly to your hand, or if I throw a ball really fast to your hand, what do you think will cause the greater change? Well, some of you guys are saying it. The ball moving slowly causes little change. Your hand might feel a gentle tap. Compared to a slow-moving ball, the same ball moving quickly causes greater change because when you catch it, your hand moves backward and you may feel a sting, like it might hurt. Greater changes, the movement of your hand and the stinging sensation show that an object's speed is related to its energy of motion. The faster the ball is moving, the greater its motion energy. Let's reread that again. So an object's speed is related to its energy of motion. The faster the ball is moving, the greater its motion of energy. So if the same ball is thrown twice, the one with the faster speed will have the greater energy. Faster the speed, the greater the energy. How do you know? You know because there are greater changes caused by the faster moving ball when you catch it. So the speed of an object is related to its energy of motion. The faster the speed, the greater the energy, because the greater of the changes that are caused. The faster a ball rolls, the more motion energy it has. Objects rolling downhill or down a ramp pick up more speed on steeper slopes. Imagine a ball rolling down a ramp. It will have greater energy of motion after rolling down a steep ramp than having rolling down a lower ramp of the same length. And some of you guys might have kind of experienced this, maybe riding your bike or skateboards or rollerblades. If you've gone down like a slow hill, you don't move, or slow hill, and not a very steep hill, but a low incline of a hill, you're not going to go very fast down it. But some of you guys have gone down some big hills. Think about all that energy and all that speed that happens when you go down that big hill. So how do we know that a fast-moving ball has more energy than that same ball when it is rolling slowly? If we let the ball hit a bucket at the bottom of the ramp, the slower-moving ball from the lower ramp will not move the bucket very far. But the faster-moving ball from the steeper ramp will knock the bucket over. The change to the bucket's position is greater when the ball was moving with more speed. That means the motion energy of the ball was greater when the ball was moving faster. And kind of going back to you riding your bicycle or skateboard or rollerblades down a hill, maybe you've kind of bumped into a friend or a family member. When you've gone slow, you guys are probably able to control yourselves, not fall over, not get hurt. But if you've hit them going fast, you probably both got hurt, one got knocked down, and so you had a lot more energy when you were going faster. So bouncing a ball shows how energy and speed are related. So you can provide evidence to show that an object causes greater change when it is moving quickly compared to the same object when it's moving slowly. So bounce a ball. Firstly, gently drop the ball. What changes? The ball bounces, but not very high. Maybe up to your shins, your knees, maybe your waist. It might make a little noise. Then throw the ball as hard against the ground. What changes compared to when you gently drop the ball? The ball bounces a lot higher, right? Maybe as high as your head, and it makes a loud noise. So now think about throwing the ball against the ground with all your strength as fast as you can. What changes compared to the other times you threw the ball? It bounces even higher. Okay, so be careful if you try that at home. It could come up really quick depending on your ball, and it could hit you in your face, so be careful. The motion energy of a fast-moving ball is greater than that when the same ball moves slowly. How do we know? You know because you can compare what changes when the ball hits the ground and bounces. Energy causes change, right? So the more energy, the greater the change. When the ball is moving at a faster speed, you know it has greater energy of motion because you can see and hear greater changes. You see a higher bounce, you hear a louder sound. Greater change is the evidence of greater energy. Okay, so if we go back up to our big question before we end, so how are energy and speed related? So the greater the energy, the greater the speed, right? The higher the speed, the higher the energy, the greater the change. Those are a couple points you should hit with your answer. And that was kind of a short and sweet lesson. Please reach out to me if you have any questions. Those that are watching this ahead of time, you're doing awesome. Keep it up. Those that are on track or getting caught up, keep it up. You're doing great. And let's end this quarter and have a great third quarter, all right? See you in the next class.